Okay, I want to take a look at sine of arc cosine of negative 2/3. Now, I know this is some angle. I'm just going to give it a name that makes me think angle. The whole thing isn't an angle. The whole thing is going to be the trig ratio I get when I plug that angle into sine. So I'm just going to indicate that this part is an angle that I'm going to choose to call theta. Now, that's not going to be one of my nice pi over 6, pi over 4, or pi over 3. I don't recognize the negative 2/3. So I'm not going to actually find what theta is in terms of radians or degrees. Would be radians because I haven't specified degrees. But I'm not going to find the measure of the angle. I'm just going to find the sine of the angle. So what I know from here is that cosine of theta has to equal negative 2/3. And theta has to be in the interval from 0 to pi, because that's the range of arc cosine. Now 0 to pi corresponds to quadrants 1 and 2. If cosine is negative, I know I'm working in quadrant 2. So I know I've got a picture like so. There's my theta, here's my reference angle alpha. Okay, now I know that cosine of that reference angle is just the absolute value of negative 2/3, so that's 2/3. So I'll label the adjacent side 2, the hypotenuse 3, and the opposite is what I'll be solving for. So then I can say 2 squared plus p squared is equal to 3 squared. 4 plus p squared equals 9. P squared is 5. P is going to be the positive square root of 5. Okay, so excellent. Now I've got this picture which tells me what quadrant I'm in and has the sides of my right triangle with the reference angle in it. That's enough for me to evaluate sine of theta. I'm going to now do my usual two-step process. I'm in quadrant 2. Sine is positive. I'm going to attach to that positive sign opposite over hypotenuse. I'm getting root 5 over 3. So notice I used the sine to get the quadrant when I was working with the inverse trig. Then I used the quadrant to get the sine when I was evaluating the trig function. I used the absolute value to label the triangle. I used the triangle to get the absolute value that I attached to that positive sign. Okay. So I'm always looking at the connection between the sine and the quadrant. Sometimes I'm using the sine to get the quadrant, sometimes I'm using the quadrant to get the sine. And then I'm always using the fact that the reference angle gives me the right absolute value. So that if I know the absolute value, I can draw the triangle. If I have the triangle, I can get the absolute value. All right, I'm going to put another one up for you folks to try. So I want, let's see, let's do sine of arctan of negative 6. Okay. So I want you folks to try that. Pause the video, work that out, come back, we'll work through it together. Welcome back. So I'm going to basically do the same thing here. I'm going to give this a name. I'm going to call it theta. That makes me think angle. Okay. And then I'm just going to write down what arctangent means. That means that tangent of theta is equal to negative 6, and theta is in the interval from negative pi over 2 to pi over 2. It's really important that I'm familiar with these intervals, although I can always figure it out, because I know I always have quadrant 1. I know it's always an adjacent quadrant where the trig function is negative. With tangent, I do have to think a little extra hard because tangent's negative in both 2 and 4, but we know we selected quadrant 4 because we wanted a continuous connected piece of graph. If I went from 0 to pi, I'd have an asymptote smack dab in the middle of my interval. Okay. All right, now if tangent is negative, I know that I'm in quadrant 4. Okay. So I'm going to draw a picture of my angle in quadrant 4. Theta would be this angle that I get by rotating in the negative direction. Alpha is my reference angle. It's basically just the opposite of theta because I'm taking the same amount of rotation but counting it as positive. Now, I know that the tangent of alpha is the absolute value of -6, which is just 6. Going to be very helpful if I write that as a fraction. So 6 is the same as 6 over 1. If I write it that way as a fraction, that gives me an opposite and an adjacent side. So I'm going to label this as 6 and this is 1. Obviously, I did not draw this to scale, but that gives me enough information to solve for the hypotenuse. So now I can say, clear some space, 1 squared plus 6 squared equals h squared. 1 plus 36 equals h squared. 37 equals h squared. H would be the positive square root of 37. And the hypotenuse is always positive, even if you're drawing in signed sides. Okay, excellent. So now I've got my picture that shows me the quadrant and has the triangle labeled. So I can say this is going to be a two-step process. I'm taking sine of this angle theta. It's in quadrant 4, so I know that sine is negative. And then, let's see, sine would be opposite over hypotenuse. So that would be 6 over root 37. Now, that gives me a correct answer, but I want to simplify it. So I'll multiply by 1 in the form of root 37 over root 37. So we get negative 6 root 37 over 37. Excellent.